Stress-free learning with
Inonyam.
create a better tomorrow. You with the program. Hard work pays off, so come and put it in. No need to wait, let the lessons begin.
Go confidently in the direction of your dreams. Live the life that you imagine.
Okay, boom. Okay, today we're about to get started. Today we'll be doing scatter plot, some new stuff under statistics, right? So what are we doing now? What is a scatter plot? A scatter plot is something that relates two sets of data on a graph. Like for example, your age versus the amount of money you have, or your race versus the amount of money you have, or also velocity versus the time, right? So it has two data sets. They say temperature and time, or something like that, right? So that's basically what scatter plots are. They relate that on one graph, so we can see the trend of that data set, right? So now regression lines are the ones that are used to show what type of trend this set of data is. To say that is it increasing trend, or is it the more time, the more time, the higher the velocity, or is it that the lower the higher the velocity, the lower the amount of time, which would result in a negative line, right? And a base fit or regression line or line of base fits is a line that's a straight line. So what formula do we use? Y is equal to mx plus c, because it's a line. But in statistics, we do not use mx plus c. What we use is a plus bx. So if you probably should be already able to tell that b in this case and scenario is your gradient. So b is equal to m. So b is equal to m, and c is equal to a, or a is equal to c, right? So basically this is still the same equation. This is still the same yx is equal to m, y is equal to mx plus c, but it's just as different variables. Why do we have these different variables? Because these variables, we can calculate them, and we should be able to calculate those variables. How do we calculate those variables? These variables, you just put them in your calculator and you get your value. So you have to be able to use your calculator to obtain A and B, right? Because most of the time they ask you to calculate the equation of regression line, right? The regression line, or the line of base fits, right? There are two things you can call it, right? So that's basically it on regression lines. And also on regression lines, do not join points. So if your point, there's 1 point there, 1 point there, 1 point there, don't go like this. No, it's a line of base fit. It's a straight line that goes through all the data. It doesn't necessarily have to start at the origin or at that apex at the corner. No, it can start there. It doesn't start anywhere, as long as it's a line of base fit in your data sets, right? So that's basically it on regression lines. So now let's look at extrapolation and interpolation. What are those? What does that mean? Extrapolation is when, okay, so, right, extrapolation is when you try to predict what value lies outside your domain and range of given data. So what does that mean? It means that we're saying that where does your value lie? Let's draw one graph where I'll show both of them. So your interpolation, right? Your interpolation, let's ask you, does your points lie within your data sets, your data that you are given, right? So if we have, let's say, a data that looks like this, right? This is my regression line. That's my base fit line. Let's say, for example, right? These are my points here. I have a point there, I have a point there, I have a point there, I have one there, I have one there, right? So that's my data set. This is my data set, right? And that's my base fit line, my regression line. Now it says determine extrapolate. If we are extrapolating, we are saying that we're looking at all the points that lie outside. That's outside your data range. That is not within your data range, as you can see. So what does interpolation mean? Interpolation is what points lie within your data, because this could have been here, it could have been here, it could have been here, as long as within your data point, the data that you are given, right? It lies within your domain and range of the data that you were given, right? So that's basically it on extrapolation and interpolation, right? So now we'll be doing the correlation coefficient.
I know a lot of you guys are curious about university life, but hey, I have to tell you, university life is good. The freedom, meeting new people, that's all great, man. But of course, you have to take everything with a pinch of salt. It depends on what course you're doing. If you're doing engineering, hey, you know, time is not that much on your side. Or doing maybe medicine, time is not one of those things. That university life they speak of, not as existent. But yeah, the freedom and you meeting new people is amazing.
Right? What is the correlation coefficient? It is R. It's represented by the letter R. Okay, correlation coefficient, right? The correlation coefficient, which is represented by R, what it basically does, it tells us how much of a fit the two variables lie. So the correlation coefficient, basically what it tells us is how good the relationship of the two variables are. How well does it say that if the amount of time increases, for example, we're doing velocity versus time, the amount of time when time is increasing, does velocity proportionally increase? That's what it's saying. It's saying how good is that relationship? That's what basically the correlation coefficient is trying to show us. Right? So it tells us how much of a fit your baseline fit is. So how perfectly does your base line of fit into your state of data, right? So let's look. There's a couple of different ways to rate how good that data is, right? So basically, this table shows you what to rate your R is, or how good the data correlates with each other, right? Correlate is how well does it fit into each other, how close to each other are all the data points. Do they form a perfectly straight line? Are all the points on the line or very close to the line, or are they not, right? So one shows us that one says that the correlation of 1, when you get a 1, R is equal to 1, it's a perfect positive correlation. What is it? It's a perfect positive correlation, right? It means that there's nothing better than 1. It's 100%. All of your points are on the line. So your base fit line is the best fit line ever. Like, there could never be a better line than that one, right? 0.9, your data is strong. The data is somewhat similar to each other, right? They're very close to each other. And 0.5 is moderate. All of these are strong, positive. All the positive numbers are positive correlation. So the 50%, 0.5, which is 50%. So the data it's okay. It's a bit of both, right? It's not perfect. It's not strong. It's just okay, right? And then 0.2 is your weak, right? It's weak. This says that your data does not have much of correlation. It is all over the place. It doesn't have much correlation. But they don't say that there isn't any correlation, but it's just weak. The correlation is very weak, right? And then we have 0 over here. 0 correlation. 0 correlation, which means there is no correlation. All of your points are all over the graph. There is no relationship between your two variables. Over here is for 0.2. There's a little bit of a relationship, right? At least it's all increasing, right? But when it's 0, there is 0 correlation. Your points are all over the place. They are scattered, right? And then below that we have negatives. So we can have, they are all the same things, but it's just negative correlation. So 0.2 is weak negative correlation. Negative 0.5, negative moderate negative correlation. Negative 0.9 strong. So what does negative mean? It means that your line is decreasing. When it's positive, it means your line is increasing, right? So So that's basically it on correlation. Let me show you a graph of what this looks like. Okay, so let's look at the graphs here. So what does it say? I'm saying R is equal to 1 for this one here. Why am I saying R is equal to 1? R is equal to 1 because if I draw a line through all of these points, it'll go right through all of them. So that means that it's perfect correlation. Let me show you. Right? So that's perfect correlation because there could be no line that's better than that one. It goes directly through, but it's not just perfect correlation, it's perfect positive correlation because that graph is increasing. The line is going up, right? And for this one here, if I draw a line right through all of the points, my line of best fit, I'm not drawing the points. I'm drawing a line of best fit, right? This line R is equal to -1. Why? Because R is decreasing. The gradient of this graph is negative. So this graph is, the straight line is decreasing. So it's perfect negative correlation, right? But it's perfect correlation, but it's negative because it's going down, right? The line of best fit is negative. And on this one, the last one over there, R is equal to 0. Why? Because I don't know where I would draw a graph over there. How can I draw a line of best fit in all of that stuff? I can't because the data has no relationship whatsoever, right? It's like saying being black and knowing how to kiss, right? There is no actual correlation between all that stuff because we can't really say for sure that if you're black you can kiss better. Anyways, yeah, so that's basically it. So there's R is equal to 0 because I can't draw a line of best fit anywhere there because it will not have any sort of relationship in that. So that is basically it on correlation coefficient, and that's basically it on statistics. Okay, boom.